The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker volcano update today. Today, Thursday, May 19th, 2022, we're going to talk about what's happening on Kilauea, which is steady pattern continues. Lava still in its active summit, ooze ups around the perimeter. We'll talk about the lava viewing. We'll talk about the VOG, which has been widespread and noted by people in the last few days especially. And then we'll also make sure we cover our earthquakes as usual. Maunaloa Volcano Watch this week is on Maunaloa's 1916 eruption. And we'll come back to 2018 at the end of our update today. Looking back 4 years ago to the third week of that eruption, reflecting back on our first update, my first update with Ikaika back 4 years ago, and all the work that's come since then. So we'll get into it, unless you want to add something off the top, Dane?
No, yeah, the 2018 eruption will be, right getting into that heat of the eruption week 3. So that'll be interesting to go back over.
Right, yeah, for sure. Yeah, it's starting to get intense a little bit, but only because we know what was to come the following week, right? And so we'll make sure to wrap around to that. And in the meantime, we'll reflect on what's happened since then, right? Which is that lava has come back into Hawaiʻi. It's been filling the summit crater without any hazard to people, really, apart from the VOG, really, that blows around and being its main hazard. So we'll spend a little more time on that here today. But to start things off with our weekly summary, we're looking at the KW camera, courtesy of the USGS Hawaiian Volcano Observatory. This is looking day and night over the last week at the summit area. And let me get my pen lined up here. I can circle some things for you guys. So there is that active lava lake area right in there, that main area right in there. And the perimeter ooze flows are coming up around this outer margin here. So all of that within this area is all crusted over lava lake, lava underneath that entire thing. And it's at the surface only in this persistent lake right here, and where it oozes up in these perimeter lava flows, which are all pretty big too. The entire crater floor is really growing in extent, and we'll cover that with some of the new maps that have come out this week too. So the overall pattern you can see is that it's kind of the same as before. So we'll move on from our KW camera for now, and turn to our thermal version, which is this F1 camera. And it's looking from similar directions, a little bit more zoomed in, so we're not getting the full margins of the lava flow here. But we see once again our persistent lake has been persistent. The little southeast pit has been persistent as well. The lava level does drop a little bit, and so you see a little bit of these rapids when you zoom into it, right in the area right in there. Not as evident in this faster thermal animation here, but you can see that's ongoing. And otherwise, you can see these pinkish, brighter orange flows that pop up around the perimeter are these ooze up flows that we've been discussing. So some here in the foreground. This is the west side of the crater. North would be that way. Would it be north? So in this northeast quadrant over here, we also see quite a lot of ooze ups, as well as over here in the south. All right, so looking closely at just that lava lake area, the active lava lake area, this is the V1 camera now, web camera from the USGS once again. And you can see a little bit of the fluctuation in lava level from the upper crust. It makes it a little more tricky when the day and night flashes through there. But one thing you can keep an eye on is this entry point of this main lava channel into that southeast pit, and you can see there when that level drops and there's like a rapids, that's a good indication that the lava level is dropping. I'll zoom it in so you guys can get a better view here. And once again, this is a whole last week, day and night, and so there you saw the character change right here. Lava level going down, you see a little bit more of the gap exposed. And as before, the circulation is coming from the west, and it goes in that way. So you see some spattering occurring along this the sinking margin of lava right over here. It's also coming in this way, and you can see the spattering zone with these spatter cones building on the side of the lake right here. And there's a third kind of off the screen now, off over here. There's another entry point just off over there as well. So these are areas you can see spattering from the viewpoint, besides all the other bubbling and stuff going on in the lava lake itself, right? And that's not to mention what else might be going on as I pull it back to the thermal view here. Even around the vent itself, there's not a whole lot of spatter all the time, but there are occasional lava flows, and there is glow, and there's other areas you might see some interesting things happening besides that main active lava lake as well. So to look at from the reverse angle from the B1 camera on the west, north is now over this way. Our active lava lake persistent area is over here, and now we're looking more at the ooze up flows, especially on this east side of the crater. So you get a better view of these ones along the south over here. You see a little bit of the ones in the northeast, but they're a little bit off the screen as well, and you get this nice view of these easternmost ones right here in the bottom. That's what's interesting to see. And as well, you can note that there are still these two large cones putting out quite a lot of venting quite a lot of gas here, and you can see them glowing, and there are occasional, it's hard to see it just flash there, occasional spatter coming from these areas as well. And so we'll talk about that as something that can be seen from the public overlook as well. All right, so turning to the maps, this is the most recent thermal map that's been released. So everything in blue is more or less the same color, and then the yellows and reds are the brighters. So at this particular image on May 10th, a little over a week ago, you see that main persistent active lava lake, and not a whole lot of ooze ups elsewhere, but you see a little bit of remnant here, and you see a little bit of remnant over here. And they're also pointing out overflow onto the lower block as this edge right over here. So That's that whole area that appears dark as a crust, but lava's underneath that entire thing, right? And if you remember, the crater is funneled deeper towards the center, right over here. So the deepest part would be over here, and then it gets shallower towards the sides, right? Kind of like a big ice cream cone. And it's been overflowing this down drop block to the north. This one over here. This area is currently encroaching upon, and at some point it'll spill over onto that ledge and then onto this lower ledge over here as well. That's where it would go next. But it's getting to the area now where it can really spread out quite a lot of area laterally, so that to actually increase the elevation of this floor and bring it higher and higher like it's been doing, it has to spread out more and more across more of this crater floor. So it'll probably won't be rising as fast, you would think, as a whole, although in some spots localized it could continue rising at similar rates. We'll have to wait and see about that. So zooming out from here, there's where that fits. That active lava lake area is that bluish zone with that red and yellow occupying perhaps 2% of that whole crater floor. And that's within this larger collapse zone. Even when it overflows, those next blocks I just pointed out, it still is going to be trapped within this big pit. And then once it fills that up, which we expect would take years, then it could spill into this other floor here, which is also within another pit, which is why this is really no danger to anyone. It's inside of what I like to call the lava stadium. It's rising higher and higher and getting better and better views from all the different parts of the volcano. Weather dependent, of course. So that's the thermal map. They've produced an actual summary map as well. And here it is, May 16th. You can see similar shape there. We have some new statistics that we'll get to here in a second, but I'll pull up the one from a month ago, which is here. Now flip it back and forth. It's hard to really see much change, but if you do, it's going to be right through here, then this zone right through there, right, on the edges of that flow. So I'll flip it a couple more times. Oh, that's the wrong way. Flip it here, back a month. It's May, April, May. So you can see it's really spreading out over this direction. Full lava extent on the map today is drawn on here, as I have to zoom this in for you guys. 237 acres, 96 hectares today. And if we go back to the one last month, 219 acres, 89 hectares. So that's 7 hectares and 18 acres, right, that have been added, right? And in the meantime, the crater floor is at 847 above sea level. And it was 840 a month ago, right? So 840 to 847, 7 meters up, and it's really spread out as 20 acres to accommodate that. So that's the pattern I'd expect for the next little while, is this number to keep going up, but more slowly, and then this number to start climbing more quickly because the lava is being able to spread out further and further across. So there's the most recent map. And of course, these statistics, this volume that we have, I should put this back on here, now up to 20.3 billion gallons. The one last month was 17.5, so we've added essentially 2.5 billion gallons, or a little over 10 million cubic meters in about a month. So that's huge numbers are kind of meaningless unless I put it into some context for you guys. So here is our volume plot for the eruption. This eruption is in red. The last eruption that was shorter than this one is in blue. You can see the last eruption began quickly and then it kind of flattened out and turned over and ended after 5 months, whereas ours is still ongoing. And ours never really got to this turnover flat part, right? It seemed like it started climbing up, and it's just been going up at a fairly steady rate, right, ever since back here early on. So the number isn't labeled on here, but this is our 75.8. Let me pull it back here. 76.8 million cubic meters, so 77 really. And so 77 up here at the top right, and our last eruption ended at 41 million cubic meters, right? So we're not quite doubled, but we're close to doubling the volume of the last eruption within the next few weeks here. So quite a lot of volume as far as accumulation here. But the important thing to note is when we actually cut it up and figure out how much volume was added since a month ago until now, and divide it by the number of days and seconds and all that, the rate right now is about 3.5 cubic meters per second. You guys can't see that. So I zoom my way in. We're now at 3.5, but we're at 3.2, and our little bump that we had a few weeks ago was a 5.9, right? So we're pretty steady at this between 2 to 3, we'll call it, right? 2, 3, 4, that range of a few cubic meters per second is our average. And really it was that the blue line that dropped off here below that 1 cubic meter per second value after about 3 months, and we haven't quite reached that point yet. So, and within the context of our own eruption, obviously we're nowhere near the peak of what we had early on, 129 cubic meters per second, but that didn't last. That was just that first phase as it broke out, and then it's really came down, and it's been essentially steady here at this low value rather than going downwards. But that's not what we're seeing. So moving on to some of the monitoring data now. Let's see if I can get the right label on here, and yep, there it is. So starting with our 1-year summit GPS, this is at the caldera at the top, and so we see this, if I zoom it way in, let me zoom in there. You know, some small scale variations, some small scale contraction, but it's fitting within this overall pattern of this extension of the crater, the north and south sides moving slightly farther apart as magma is accumulating below and causing that spreading, that sprawling to happen, with short-term variations in between, which in the past have reflected the deflation-inflation events or variations in supply in short term. So little wiggles, but overall same pattern. And the same thing can be said on the lower East Rift Zone. Actually, this is the Middle East Rift Zone at Pu'u'o, I should say, with this contraction happening ongoing throughout the whole eruption. Sometimes some small variations. If I zoom it way in here, the variation is actually downwards, so still little variations, and overall the trend has been pretty steady there. The overall lava depth from the beginning of the eruption until now has been growing essentially pretty steady. This is pretty similar to that volume plot I just showed you guys, right, with a steep beginning and then a kind of almost a linear growth after that, right, which is not exactly what you'd expect because it is a cone, so you really think it should flatten out at some point a little bit more. But it's been going pretty well. Of course, keeping in mind this is one data point on the surface of that crust. And given that within the last week, it started off at around, we'll call it 350-ish, and now we're at 355, a 5-meter gain in a week in that one spot. You can see that it was actually a slower climb, and then we had a couple pop-ups right here, so it's not quite clear if this was like a raising of that crust or lava flow flowed over top of that area, because we're not exactly sure where that rangefinder is pointing on that crest of the lake. But in any case, you can see it's interesting to see how this happens in discrete steps right here, right? And this is interesting because the tilt, as you see just below here, reflecting the pressure underground, spreading, tilting of the ground around the volcanoes, the crater edges, the caldera edges. We're seeing a range of 1 to -1, 2 microradians, not a huge range, and not any huge swings within any of this data. There's actually been almost kind of steadily flat down here at the bottom, right, with not a whole lot of movement while this step up is happening. So it's still just filling, and you can imagine that as it becomes a wider area, over 200 acres, that it's having to adjust one side and the other side, and one side and the other side, or one area, and there could be a lot of variation from point to point on that crater floor. So, all right, I had a question come in. I'll throw it in right in here. I have a question from Solomon Parker. What's the crust floating on? What's holding up the crust? Ice floats on water, but rock doesn't float on lava. So how does that old section of crust and the spatter cones float on lava? So, yeah, that's generally true, Solomon. But to say that rock doesn't float on lava, that's the issue there, because clearly we're seeing some kinds of rock do float on lava. And this comes back to what kind of rock that is in the center of that crust. And we believe that that was part of that very early December 2020 fountaining event of the volcano when it began to put lava out into the crater. There was still a pond of water then. The lava fell into the water and was probably very quickly quenched. So we think there's a lot of almost like a pumice-like core of that lava island that's in the center. That when that thing first came out, then lava came out and flooded the crater, made a giant lake. That piece of pumice core, whatever, was coated in lava and it began to grow and it got spattered on top of, and all kinds of morphological changes. But the core of it is still clearly not denser than the lava lake that's rising below it. And it's just that middle part that has that oldest part of the crust that's rising upwards, and the edges are not. And that's why you see the ooze up flows coming around the edges rather than coming through the middle. The middle popping up and then leaking out from the sides there. And so we're not having any more of that stuff form. It's not like the whole crust everywhere is lifting up. It's that center most buoyant core of it that dates back to how it formed. So great question, and good little note to add here to our discussion. Mahalo. Let's see here. While I'm looking at the questions, acreage of the current active lava lake. I didn't see it listed on here.
Yeah, I was looking for it right now, and I'm not seeing it exactly.
But if I were to go at
maybe on one of those.
About 2% of 237 acres would be my best estimate at this point, right? So what would that give us?
Like an acre-ish, a little over. 2% of 200 and something? Is that what you said?
237.
Yeah. So a little over 1%.
A little over 1%. So that's the best estimate I can give.
Acre,
Joel, yeah.
A little over 1 acre, sorry.
Yeah. So mahalo for the question, Joel. That's our best guess. A little ballpark about around an acre or so.
Yeah.
All right. So let me get back to our monitoring data here. And we're looking at the last week. We're going to zoom out to the last month. And here's our most recent step in the last month plot. There's a little bit of noise coming in, probably because of the variable winds and fog and rain clouds, kinds of weather effects here. So we can ignore that little noise and just consider the trend upwards. And then this is the interesting stepwise here at the end. You can see that there have been these kind of flatter zones and then ramp ups and flatter zones, right? So in that sense, it's a little bit more accentuated, but similar kind of pattern as we've been pointing out for the last month. And in the past, these flatter zones periods have matched up with the deflation-inflation events, right? And that's what was interesting here and here again. And really, in the tilt world, this is the last week right over here. It's just this high part. We basically have been sitting high for the last week without a whole lot of change. We'll have no big deflation-inflation events in the last week. And perhaps, what you're seeing as far as this is just the mechanics of the crust like catching, and that it is buoyant, but it's also getting attached to all the lava around it, and maybe it's hanging up, and suddenly it can pop up at some point when it overcomes that frictional force or whatever is holding it back. So small scale changes, nothing major happening there, but interesting to look at as far as the process. The gas has not been reported. No new data points measured within the last week reported back here. But you can see that the pattern doesn't really lead you to believe there's a whole lot of change, right? We have seen some higher ranges like appear during these non-deflation inflation event periods. So perhaps we could be somewhere that high over here, seeing as we have another no deflation inflation event period here as well. But in any case, it's all been within the range of what we've termed normal for this eruption now, and we did have a comment on that, so I will get to that here very shortly. But we'll start to connect this SO2 data here to the VOG, and we're going to talk about hazards essentially as our next topic here. So switching from our monitoring to the hazards, and focusing in particular on a VOG, right? This is from a USGS pamphlet showing the essential processes that occur when the gas is released in a volcano. Here's a volcano putting out gas and ash, SO2, CO2, HCl, HF. All those things can be in that main ash plume. A lot of that stays nearby or reacts or is in low concentrations. But what we're concerned about mostly is this SO2 right in here. The SO2, as it flies downwind through the air, is affected by the atmosphere where there is water available, sunlight as well, photochemistry, that essentially is changing this pure SO2 gas into more of these sulfuric acid compounds here, right? And other sulfate particulates as well, which I think somewhere on here might be listed towards the end here. That'd be more particulates, right? Since you're changing from more gas to more particles that have sulfur in them. And so that's kind of what's happening as a gas is flying through the air. So pulling up the VOG forecast from weather.hawaii.edu, the VOG mapping project, VMAP project here. You can see that right now the VOG is blowing a lot to the north, encompassing the Hilo areas, swirling around. It's coming back to the southwest. It seems to be going through the saddle, reaching these upper areas of Kona. It seems to be swinging all the way around to the north tip of the island. You see all the way to Hawaii and Honoka and Waipio, all getting affected at some point here. If not right now, then in the hours and the day to come here, that's what we have in stock. And that has been the pattern here, which is a little bit unusual for this time of the year. Usually it's cleared up by now, but the winter weather has lasted a little longer this year. So here it is. And if I zoom it out a little bit to start things off, you'll see that there are effects of this VOG as well that can impact Maui as well. Sometimes when the tonnage coming out is really, really high, you can see these effects all the way down on Oahu and Kauai as well. So that's the direction the VOG is going, and along those lines, I wanted to pull up a couple of comments from our streams, right? So here's a YouTube comment this one's from 4 days ago from Anita Bachman. Thanks for your comment, Anita. Maui, Kīlauea. For months now, the VOG is so thick, causing sinus headaches, irritated nervous system, and fatigue. That's what you call normal range? The VOG is only coming worse, thicker, and is out of normal range since a long time, maybe since eruption started. I wish scientists wouldn't cover up the truth. Since eruption started to now, you have a huge increase in VOG. So yes, thanks for your comment, Anita. Thanks for supporting us here and supporting our stream. When I say normal, I am saying for this eruption, right? So to put things in a little bit bigger perspective, I wanted to show this plot that's a little bit dated now, but this is showing the SO2 emissions by year here, and this is going through 2019 only. So really, this is megatons, which is kind of the whole year added up. We're not looking at per day anymore, right? On this plot, but you can see that prior to 83, we had very low levels of gas coming out. That's what's shown right over here. Very low levels, much less than 1 megaton, right? Pool eruption begins, and we jump up to maybe an order of magnitude of 1 megaton, a little less than it actually, right? That's the pattern we have for a long time, 83 all the way until 2008. And what happens in 2008? In 2008 is when we had the lava lake come into Halemaʻumaʻu. Right, Pu'o still continued, but Halemaʻumaʻu lava lake opened up in 2008. You can see the emissions jumped up right away, right there. And it actually stayed at this level from 2008 until 2017. Right, and then what is clearly abnormal was 2018, that huge spike during eruption. 2018 is right there. Right, and really what's not shown on this plot, which if I could draw it in, you'd see that 2019 and 2020 would both be very, very, very short graphs, because the 2020 eruption was only only had what was it, like 10 days, 11 days in the end of 2020.
About like that, yeah.
Yeah, I think that's right. So you'd see 2021 would come back up. 2020 would be short. 2021 would probably come back up to this same range right here, because that's more or less where we are now. That long-term average was about 5,000 tons per day for this era. And we are maybe not at 5,000 tons per day now, but we've been up to 5,000. We've been to 2,000. That's more or less a range. So our bars would be probably an order of something like this for 2021 and 2022. So when I say normal, it means normal within since 2020, for one, but it also means normal all the way back to 2008, when we've had similar levels. Since 2008, really the only abnormal times have been the 2018 eruption with a abnormal high, and then 2 years following it with abnormal lows. So we're back to quote unquote one kind of normal, right? And I totally get your point, Anita. I'm not trying to criticize a comment at all, right? I'm just saying like this is worth talking about because you're not the only one who has that question of what is normal really, and normal for someone who was here prior to 83 is much different than normal for someone who is talking about between 83 and 2008, and that's very much a different normal than since 2008, right? So that's just to try to clarify there what is normal, and clearly there is an effect of the VOG on Maui. That's what I'm trying to show here, and it has been much worse than this at sometimes in the past, especially with much higher amounts of gas coming out. So there's two things that have to happen for the VOG to really be this hazardous. One is the amount of gas coming out has to be high, and then two, the wind has to blow it where people are. So we have moderate amounts coming out now. Is what I would call moderate, considering 2018 has to be the high, right? So it's not low, but it's not high either. It's somewhere in between. And it's enough to impact our whole island and Maui as well at current time, right? And when it was high and blowing, it would impact all the way to Kauai as well. Speaking back to 2018. Okay, so one other comment I wanted to pull out from YouTube, and this is goes back to 3 weeks ago, and this is one that I wanted to pull out to read last week, but finally made it this week. Here it is. From TJ, mahalo TJ, from Volcano. Here's what he says. Long-term resident, he or she. Long-term resident. Gas emissions are bad in Volcano Village. They improve to a comfortable level during deflation events, and then get worse when the lava rises again. The actual haze isn't too bad with the trades. SO2 makes us pretty sick, and it fluctuates in intensity throughout the day. Mornings before 9 o'clock, the air is the best. The sun can sometimes intensify the effects. This will be noticed with the plants. They will turn black or bleach out. There are other gases that are odorless and not monitored that may contribute to feeling ill, like the extreme sleepiness when you just can't stay awake. We call that comatose. It is just so awesome. Just don't live by it. Accumulative. I gently appreciate you guys, greatly appreciate you guys and others who show such great views. That is good enough for me. I saw many beautiful live scenes when it was smaller before 2018. My imagination can see the awesomeness. Mahalo for all you do. So mahalo for your comment, TJ. Mostly this VOG part is what I really want to make sure we share. Make sure everyone is hearing your message here. That we have reports from Volcano really close to the national park and as far away as Maui, right? And of course, there's other discussions happening online here of suggestions of what might help. And so, mahalo you guys for sharing. Anyone else who would like to share their stories with us as well of what the VOG has been like, please feel free to do so. And we do like to highlight those as an ongoing impact of the eruption here, which is not always discussed.
Yeah, and there's also one other thing to add here is they're talking about like some of the other gases that might be associated. We did see after the eruption in 2018 how some people would be impacted by the hydrogen sulfide, the H2S, more so than others. It was almost to the point where certain people had almost an allergic reaction to it. That's how dramatic the difference between some people were. We'd go to areas, me and you would go to areas and we'd be fine, and other people couldn't be in the vicinity. And it's like, I didn't even smell anything type of thing. But we've seen enough of that there's enough for us to say that, basically. Yeah,
for sure. Every human has a different sensitivity to it, right? And not just it, right? There are different components of it, and depending on what kind of process is happening, you might have different proportions of those components, right? So that's something we can look at a little bit as well. Let me here show you guys this. This is another little summary from USGS. Volcanic gases are all colorless and visible, but have different odors. So when we discussed these gases before, SO2, struck match or fireworks. H2S, rotten egg smell. HF, hydrogen fluoride and hydrogen chloride, strong, irritating, and pungent. CO2 and radon are odorless, but those are all volcanic gases that, like CO2 and radon, that could be, depending where they're dispersing, and if people are breathing them, could be causing some effects, perhaps as well, right? That's something to note. Here is another chart from USGS, temporary volcanic air pollution health effects, and you can see here SO2 is when we talk about the most, but whenever we talk about SO2, we're talking about implying all these other things as well, right? There's H2S, CO2, HF, HCl, and particulate matter here as well. And as far as irritation in the nose, throat, eyes, and skin, all of them, cough and phlegm, all of them. Chest, lung tightness, or irritation, all of them. Shortness of breath, all of them. Headache, all of them. Aggravation of asthma, all of them except CO2. Fatigue or dizziness, SO2, H2S, CO2. Rapid breathing, CO2. Nausea could be SO2, H2S, or CO2. And cardiovascular effects at high concentrations with SO2, HF, and particulate matter here. All right, just a little summary, all the different things that can occur here, and everyone has got different sensitivities, and of course, when the alerts levels are put out, those have in their notations, right? If you're in a sensitive group, this is when you might want to take precaution. Right, so that's embedded in our alert system now. Not that we have many alerts that have gotten put out. We can look at Hawaiʻi Volcanoes National Park, and you can see currently. Let's see if I can try to reload this and see if it gives me any wind direction or if it's giving me slack wind. Yeah, so it's showing me 2 miles an hour from the southeast. That's basically nothing. So all that fog is going to be accumulating in some of these areas, and some of them may turn unhealthy at times, right? So I thought I just saw this was orange when I first turned it on, but now it seems to have cycled through. I can, on this page, which is hawaiiso2network.com, you can scroll down here, right? Here's the advisory level of air quality, right? You can see that unhealthy for sensitive groups is in orange right there, and moderate just below that. So here's our plot for our history for average across a day, right? So just today, you can see that we've been in orange quite a bit, and in a yellow quite a bit as well, with clear periods of calm and green in between it. Doesn't mean the bug necessarily has gone away, but it's dropped down to those lower levels there, right? So this is like the summary for the whole park. You can click down here where it says advisory history by site. Right there, you click on that, and that takes you to here. We'll reload it. So this gives you by station. So I don't know how well you guys can see that. There's a lot of little graphs. So if I zoom it way in, for example, this one, that's Kilauea Visitor Center. For the last 24 hours, you can see that it was in the green most of yesterday evening until this morning. And then is when the visitor center started to show these effects, right? Maybe around the middle of the day at the visitor center today. But that's not the only place in the park, of course. You can see over at the campground, got into orange a few times. I'm not sure if there is a sensor by Kīlauea itself. You can see the steam vents got into the orange a few times, not just today, but also yesterday. Right, reflecting the reports we're getting from the community here. And otherwise, that's it that's showing up on here as far as on the monitors, right? The visitor center is not exactly where the viewing is, but it maybe is a decent indication of which way the wind is blowing there. So something to be alert for, and that if you're planning to come and visit, you should definitely check the National Park website for the recommendations and all of that, right? So that is the park summary, and the park is also noting this. Here is a park Facebook page from today. What's up with the smoke and haze? And a review of the VOG, review of latest conditions, hawaiiso2network.com once again. And so everyone's talking about it, so are we, and it's our focus for today here. Right, we've gone through some of that. Let's look at some of the viewing here. Within a national park, the main area we talk about for viewing is Kīlauea. Of course, there's Kupi-na-Ipali over here in the east, and Uekahuna in the north as well. Right, there's other areas you can see. The main vent is visible from Kīlauea in the south, but as it's coming up and up, it's also getting more visible from over here in the east. So it kind of depends which part of the crater floor. As we mentioned before, over 200 acres of area, so you can see something from everywhere. It's just a matter of whether lava is actually visible from there. And for the past week, and the last couple of weeks, really, last few weeks, it has been for many areas, with all the ooze flows making it accessible to viewers from the north. Less ooze flows visible from the east, but the ones in the back certainly are, as well as a vent over there, and from the south you see most of it as well. So once again, we're going to turn to our friends Lou and Anna from Two Pineapples, who are going to share with us some of their photos and a little bit of video that helps us show you guys what the viewing actually is like. So let's switch our caption here to our viewing report, which is kind of mixed in with our hazard summary, right? But here are these guys this morning walking out through that VOG. Down a closed Chinikaras Road in the National Park. So you can see the VOG is pretty thick there. They actually had to leave earlier than they would have liked to. But of course we're aware of those hazards. Here is the actual view of the viewpoint. Overlook is right over here. You can see the gas is blowing towards the right here, right? Kind of towards the viewer, toward the visitor centers over in this direction, but you can see it's kind of the opposite. Most of the time we see this gas blowing off in this direction. So if you see this, that's the reason why. The weather coming into effect here. And we have a few clips here, excerpts as usual from Two Pineapples. Check them out on YouTube. These guys are streaming live whenever they can. Here's a wide panned out view. You can see sped up the main circulation of the lava lake. And then we'll zoom into that southeast pit area. Lots of nice bubbling happening there. Get it a little bit more. Thanks for that section there. See some of that bubbling. Let's see the circulation coming from right to left and spattering across. Right, let's see the camera shaking a little bit because it can be windy. It is zoomed in a long way to be able to see this here. There's some cool little lava driplets on the side of the wall channel as I'm getting dragged and strung out. And we'll zoom out and get a view of the wider crater here. So panning over, some ooze up flows and I'm back there, but looking down, this looks like one of those taller cones, right, that we're looking at in the middle of the crater floor. And some amazing sequences of spatter bursts here coming from this cone, this guy's comp. So congratulations, you guys. Some epic views once again. The spattering goes on longer than I'll show it to you guys because we could probably show it for hours and hours and hours, and that would be a different kind of volcano report that you guys can check out on Two Pineapples. So we'll just leave this as a little review. Enjoy the fireworks here a little bit longer before we move on to some more lava viewing. A lot of gas coming out there, yeah. That's what's driving all those bursts there. So here is the S1 camera, which has often been our proxy for that viewpoint, right? So you can see over here, active lava lake, ooze-ups in the south, and the west, and the north, and lots of activity you see there, as well as that little rapids that you see coming in. See if I can zoom it into there a little more so you can get a closer view from the other angle of the southeast pit when the rapids form once the lava level drops a little bit. It happens a couple of times in there. And so clearly our laser is not pointing into this pit, it's pointing somewhere, I would suspect somewhere around here, if I had to guess. Right, that's the summary, decent viewing from the south. And if you're at the north at Uikahuna, then we will once again use the proxy, the KW camera, and zoom into this little corner way over here. This is the corner you likely can see from that KW overlook, or that Uikahuna overlook on this KW camera here. And you can see persistent, low-level lava flows kind of all week, right? So something to see. Maybe not the huge overflows that you used to see before from the vent, right? But as far as what you can see, like not that many active lava lake, but lots of small flows, also visible with a lot less walking from the north at Uikahuna right over there. Right, so epic viewing continues. It's still the great time to see the volcano. We're going to switch now to our media of the week. From the USGS, starting with the update from today of some photographs. So this is zooming into that southeast pit we were just looking at right there. There is that channel rapids and the spatter that's built up around the edge of the pit. Movement going in this way, and the lava as it's draining down somewhere right over here. All the gas is refusing to subduct there, and it's bubbling back up and spattering, causing the lava to shoot out and fall on the edges there. That's basically what's going on there. Zoomed out, we're looking into that southeast pit right over there. There's that main lava lake. You can see a little bit of a gap on this photograph, so a little bit of a lower lava level that corresponds with that farther exposed gap, and that little channel. And one thing I maybe should have mentioned, no intact crust, which shows this whole surface has been churning and moving, right? Like over here, you see these silver plates of lava crust. That's maybe only a few inches thick or so, but still cooling to form a crust on top of the lava lake, moving slowly enough. And in here, you see it all breaking apart, just little chunks of it swirling around. So fascinating stuff there. Loud whooshing and roiling noises are sometimes audible from Kanakakoi Public Overlook. I don't mention this as often, right, because I'm showing you guys a video. A lot of times I'm talking over them, but a lot of times you can hear things over from the overlook, right? So you can, during breaks in conversation, you can hear the volcano producing those sounds, especially if you're there early when there's not a lot of people. Okay, so zooming in now to the vent degassing in the morning of May 18th. This one is captioned as 56 feet tall, 17 meters. And a small puka visible. Small hole with glow. Well, right there, actually. There's a hole with glow right there. This is the one we saw some low-level flows coming out of on that thermal image there. So 56 feet, about 60, we'll call it, 50 to 60 feet, which is right in line with what we were estimating based on previous features on there as well. Okay, we'll move on to the next set of photographs, which is from a few days ago and goes back to last week. So once again, in view of that lava lake, active lava lake. When lava level is a bit higher, you don't see quite as much of that cliff, especially over here on the side. And you don't see those rapids and redness exposed on the crust of that pit lake. So, well, it's still going in there, but everything is at a slightly higher level right there. Scroll it down. They do give some dimensions here, so we can use these in the future to maybe put superimpose some stuff on there now that we have some new dimensions. The lava lake's approximately 168 meters, 550 feet east-west, top to bottom, in that direction, right there. That distance is 551 feet, 168 meters. In the other direction, it's skinnier, about 200 feet north-south, 60 meters in this dimension over here. So for those of you guys have been asking for some new measurements, and we stated that last week, mahalo to the USGS for providing us some. Okay, the more zoomed out view. So there is that whole lava lake right in there within a larger crater floor, which is covering that entire extent right there. Okay, so also last week there was an overflight down the lower east rift zone. So since we've been talking about 2018, you're going to do some more of that here today. I thought it would be good to include these as well. So 1 week ago, this is 4 years on from the eruption, how the recovery is going. We're looking at Kapoho crater, known as Green Mountain. Green Lake used to be in the middle here before the lava came and filled it in, of course. You can see the caretakers of the property doing some recovery work. There's a road in and a little pad with some materials on there, appears. And so good to see the recovery happening, although it's clearly not anywhere near back to what it was like before. You can see all the lava surrounding it, right? The first lava flow that came around from Fissure 8 in early June, and then in July reverted and redirected back across towards Ahalanui there. And then we can see the traces of the new road that were built across that first road to be recovered. And then since then, more of the residential stuff coming in afterwards. So just one at the far eastern end, that's Kapoho. Looking at the area of Leilani Estates, here is the fissure line. See some of these cones. There is Ahu'aila'au, Fissure 8. And you can see if I zoom it in, let's just click on this one all the way through so I can zoom it in, because I would like to blow it up more. Because that gives us a little bit better view of the part of Leilani that still remains here in the west, right? You can see looking a lot greener than it had. You still see a lot of these brown dead trunks of trees at the closest part of the flow margin right through here. You see a little bit of gas coming out behind Ahu'aila'au and all the way in Leilani as well. And if you look way back here in the background, back across Highway 130, the Ala'ili area, you can still see some fume coming out there as well. Now, we discussed this a little bit last week. There was quite a lot of gas, a lot of rain recently, so that adds to the steam and the gas, but it is all visible. And that is a current view here. Dane,
they caught it on a day without. Yeah, they caught it on a day without much steam. Really, like they got great conditions considering the last couple of weeks down here. Those things have been steaming pretty hard with all the rain that we've been getting.
So it could be showing a lot more than this.
Right. They are getting pretty far up that hillside for the vantage, so I don't know, they might be using some kind of lens trick or something, which is minimizing the amount that we see visually. I'm not sure exactly.
Right.
But yeah, I'm just telling you, down here, like going to those things, they've been pretty steamy recently with all the rain.
Right. Yeah.
Not too much in the gas lingering, but definitely steamy.
And you're smelling mostly steam. You're not smelling as much H2S.
I haven't. Yeah, from where I am, I haven't smelt any of it really. I don't walk exactly right by the vents, but near them, and haven't gotten any whiffs of anything.
Right on. Well, thanks for that on-the-ground report. Very useful to have that. So let's look at the last photograph here. Let me cycle it back. And the last photograph shared here is Isaac Hale Beach Park, also known as Pohuiki Bay. That's been filled in by the sand partially here. Here's that new beach. There's that old boat ramp and the remains of a little warm pond right in here. Parking lot and a new flow. And so this is, of course, was an interesting area that we still talk about a lot today. This is an area that looking back at we'll play you guys one of our first update videos with Ikaika from a year ago. And May 20th last year was, early on when lava had first come down towards that southern coast. And he had gone out in his boat and seen Pohuiki and seen Kīlauea and Malama Flats, Malama Key area, that whole area. Even then, with a kind of glancing blow that it took at that point in time, was clearly going to be a lot different for everyone. So it's been quite a journey through the whole eruption, since eruption, this whole area. And maybe I'll leave it at that until a little bit later here. Unless you want to jump in with anything, Dane.
Yeah, I was just looking at this photo thinking to myself, man, with what we know from the state and the county that's coming down the pipeline, I don't know exactly how much we can talk about, but we know that there's going to be some significant changes and improvements, construction, dredging, all kinds of projects down there, that this picture is going to look incredibly different, say in 5 years from now. This photo that we're looking at now, it would be almost night and day again.
Yeah, 5 years. Yeah, in 5 years, we hope to see quite a lot of progress, right? And yeah, we can't talk in too much detail, but really, as you develop an area, you want to of course be concerned with the hazards, right? You want to of course be concerned with the culture, the tradition, the history. There's all kinds of aspects, right? This is an area that's been important for boating and fishing. It's an area that's been important for swimming. It's an area that's been important for family gatherings. There's all kinds of different uses that all kind of overlap into one single area, which is why the area is so valued and treasured and important, of course, is because everything can happen there. So as they plan for it, they have to address all the different facets of that sufficiently, which is a huge challenge. Huge challenge.
And then you got to pass all the hurdles with the federal funding and all that kind of stuff as well. So yeah, lots of hurdles in there. Yeah.
So we'll see. We'll look forward to reporting some positive developments over the next few years here, and good to note what it looks like today, right? Very different than 4 years ago, and hopefully very different than 4 years from now. Again, wait and see here. All right, so just to remind myself, this is all coming from USGS data. So mahalo to the USGS Hawaiian Volcano Observatory for providing all this data, or just repackaging it here to share with you guys, trying to make it all coherent and related. So, but they are the source of all the original information here. Okay, that is, I believe, Dane, our halfway point. So we can say some thank yous when you're ready.
Yeah. First, I want to thank everybody that tuned in today. We appreciate viewers that, especially return and keep coming every week. Rely on you to really spread this content, the algorithms on YouTube and all that kind of stuff, which can be done with the likes, the shares, and the subscriptions. I know it gets tiring to hear, but it really does help the channel out. We also have a couple people that did make some super chats. Want to acknowledge them. Chris Kiki with a $20 super chat says, always appreciate all your hard work, guys. Appreciate you and the support, Chris.
Mahalo, Chris. Mahalo, Dane. Dane, I think I got you frozen on my screen here. Will you just real quick reset your camera? Yes.
All right, that should get it.
Thank you.
All right. Second one is Gary Bryan, a longtime supporter. Thanks, guys, for these updates. He has a $35 super chat and all the prep that goes into them. Appreciate it, Gary.
Mahalo, Gary.
And then we also have a $20 super chat from Langer, who says, always interesting. Thanks, guys. And we do want to thank also our longtime sponsor, Kilauea's Bar and Grill. They got 2 locations, one in Pahoa, one in Orchid Land. The Orchid Land location is still pretty new, fresh establishment. They got live music on, I think they're doing it every Thursday now. So Akaika Marzo's playing tonight. So definitely check them out and let them know Tracker sent you. And we appreciate their longtime support.
Yeah, he's starting in half an hour, so we'll probably be going still a little bit. And if you guys are watching us, you might want to pause the video, make sure you have a reservation for your table, and head over there. Yeah, or plan next week or something. But
yeah, it might be planned next week.
Or maybe check out. Well, maybe there'll be some music shared online too. We'll keep an eye on that too.
Yeah, I'm actually heading over there after this, so maybe I'll see you there.
All right.
All right. And also, where were we? All right, I think we can get into some questions, yeah?
Yeah.
All right, so there was one here, and I'm going to kind of piece it together because I heard it in a few different parts. But looking at the inside that active lava lake that we have there, along that one particular edge, you can see there's a decent amount of spattering happening. And the question is, could there be some vent feeding magma from beneath that spot to make that turbulent area?
So there could be fissures that are underneath that crusts somewhere, right? And they could be feeding lava out of sight that we have really no way to keep track of visually, right? Maybe if you had some fancier instrumentation, you could get at some of that a little bit. But in that case, because the circulation is going kind of towards that spattering source, rather than away, if it was a source of magma coming into the area, you'd expect the magma to be flowing away from there. You'd expect some gas to be spattering up, yes, but magma to be flowing away from there. Like we saw the first day of the eruption, when magma, when the lava was coming up through the lava lake in the central area south of that main island. It was fountaining up through the lake itself, and it was causing waves to ripple away from it, right? Like these ripples that were going away. So that, I don't know if I can find a video right now, but that's what could happen when it's coming up through the bottom, is the circulation and kind of go away from there. The circulation is going towards it, then it's usually the opposite effect, and that's that kind of recycling of the magma, right? The magma essentially is coming up gas rich. The gas is flying away, bubbling up and flying away. You see it, all the gas, all the fog has been talking about all day. Then it becomes slightly denser and cooler, and as it's moving towards the edge at some point, it's going somewhere. In that area, there's some kind of drain that's been established for a while, some kind of tube or some pathway that goes back beneath the crust. So we've seen the lava go in there for a long time. And when it does that and dives under, whatever gas is still trapped in the lava doesn't like getting pulled down and getting sucked under. So as it's getting pulled down, some of that stuff will resist and pop back up. And so the gas bubbles that are popping back up out of the lava as the lava is going down, that's what's causing the spattering at that sinking source. And that's something that's been described for, over 100 years. The first Western visitors wrote those things down. Frank Perret wrote down, they called them grottos. Jagger talked about these grottos, like where the lava would be going into the edge, and it looked like a little cave that the lava was going into, and it was overhung with little stalactites, and that's the grotto. That's exactly what we're looking at right there. So same kind of thing is typical. It can go both ways, and in this particular case, at that particular location, I believe that it's consistent, more consistent with the recycling of the lava than it is of the lava coming up and out and through and pushing things out and spreading away.
All right. Got a question here from Gary Bryan, who asks, does the increased area of the lava lake surface cause a decrease in average surface pressure, allowing more gaseous venting?
So that's a good question, but I mean, really, it's not like the lake is all liquid on a surface at the same time, at least anymore. Maybe the first day when the lava was really hot and gaseous, that was the case, and that you could have those kind of effects then. But now you have so much hardened crust that most of the gas is actually trapped inside of that, inside the lava, inside the crust, right? So, and that's a much smaller scale thing. So even as you increase the area, you're just having that thing happen more often and kind of spread out across there, right? So what's along those lines, Gary, that same kind of process is really when you think about that piston crust in the middle getting lifted up and lava like oozing out the sides of it, right? That's in a way more gas, more venting of that gas-rich lava, right? And in that sense, yes, the more that thing gets lifted up and the more it can leak out, the more that can happen. So that's the take that I can put on it right now. Maybe I could do better, but
I think that gets it. We got one from Richard here. He asks, is there a chance Maunaloa could break the pattern and begin erupting at the same time Kilauea is erupting?
Yeah, there's always a chance, right? I mean, we're not any, all-knowing beings or anything, and we're just, trying to piece together the best of it as humans here, the best patterns, and we think we see a pattern, but patterns are often broken, and certainly Maunaloa could do something at the same time. However, all that said, we don't see any signs of that happening right now. If that were to be the case, we'd expect to see the signals at both volcanoes at the same time, and we're not seeing that, at least. So on the basis of that, we don't expect Maunaloa to do anything dramatic until we see some signs of buildup and some change. We'll discuss Maunaloa a little bit more here after our break, but maybe that's enough for now on Maunaloa.
All right. And we'll do one more question for this part. Kind of a weird one, but the question is how would the caldera look like if we had the 2020 eruption and the 2021 eruption take place and there wasn't a collapse prior? So 2018 didn't collapse somehow. Would it be filling in the bottom of the caldera if we had that amount of volume come through into separate eruptions, or what do you think?
I believe so. I would have to go and confirm the numbers, but that pit of Hale Mau was half-mile wide or so, and it was not quite 300 feet deep, maybe 80 meters or so, something like that. Right. So it's still a huge amount of stuff, but it's not, we've had 77 plus 41, right? That's what?
77, 41.
118?
Yeah.
Million cubic meters, right? That's a lot. That's a lot.
It's a lot. That caldera floor, though, is quite big.
Yeah, so it would still be paving. Yeah, it would have filled out that innermost pit that existed before the collapse, and then it would have been spreading across the main caldera floor. Would be my presumption, and I can go check the numbers, but that's probably true.
All right. Well, we will do one more segment of Q&A at the end, but I think we have some stuff to talk about some previous eruptions on Kilauea and Maunaloa.
Yeah, so we'll go a little longer today. We'll just wrap it up on the earthquakes in Maunaloa and Volcano Watch, and then we're going to turn to 2018 because we feel like getting into the perhaps the more populous trauma, right? As, the volcano started to affect more people by this time 4 years ago, more and more with each passing week, and it was about to really explode. So, as far as who was affected, so spend a little more time on that this week, but we'll start it off as usual with our earthquakes here. So, looking at our recent earthquakes, here's a USGS map. Typical pattern. There's kind of one off here off of Maui, 2.8 at 0.6 kilometers depth. Pretty shallow, but just a one-off. Some adjustment of the crust there, or some old fault line or something that's not really worth worrying about because it's one-off event. On Hawaii Island itself, we still have a Pahala earthquake sequence still continuing. We've got a couple further off to the south here, 3.5 and a 3.2. 3.5 very deep, 37 kilometers down, and a 3.2 at 13 kilometers deep. So some adjustments over here to the side, a little bit off of the main Pahala zone that we typically see. A little bit off of Loihi would be more over here, or volcano formerly known as Loihi. Oh, I wish I had it memorized better. I'm going to keep working on that in between weeks here. Most recent earthquake on Pahala, 1.8, very deep. Kilauea, typical patterns. Low level around the summit, low level south flank. Maunaloa, also low patterns as well. So not a whole lot to talk about there. But wanted to show it to you guys anyways. Here are the plots on Kilauea for the last year. We're still down here at this low value. Really nothing happening there for the last month. And pretty steady. Probably averaging 30 to 40 earthquakes per day. That's background kind of low levels for us here on Hawaii. Over the last week in the Kilauea area, Pahala is most of the action, a little bit at the summit and south flank, nothing abnormal. Same views as we've been seeing for a while. Not as many deep earthquakes, but they kind of come and go on a week-to-week timeline. For the last month, the pattern's more obvious. We discussed this at more length last week, so I'll keep it shorter on earthquakes this week here. Let's move on to Maunaloa. Earthquakes in Maunaloa, also at low levels. The GPS distance across the caldera perhaps is a little more convincingly extending now, right? Not at any kind of alarming rate, but at a slow rate, similar to what we saw over here. It might do a similar kind of thing again, where the volcano goes through the cycle of filling underground and then kind of spreading itself out and then filling and spreading. It's kind of a big thing, so it's a little bit more intricate, I suppose, in Kilauea. Maybe not intricate, but extended, right? It's the whole process is a little bit more drawn out because of the size of the volcano, I would expect. So that's the GPS, and we will turn to our Volcano Watch article here. Let me switch our... We actually went through a Maunaloa summary that I forgot to put up, and we are to the USGS Volcano Watch. All right, lessons from Maunaloa's 1916 eruption is this week's Volcano Watch. So, 1916 was not only the birth of Hawaiʻi Volcanoes National Park, but it is also remembered for the eruption of the Honomalino flow from the southwest rift zone of Mauna Loa 106 years ago. The eruption had two phases, as many Mauna Loa eruptions do. An upper rift zone / summit area phase. You can see the earliest phase here, viewed from kind of Volcano House area in Hawaiʻi Volcanoes National Park. Here's Uekahuna, here's Kilauea Caldera down here, Steaming Bluffs over here, right? And you can see, not exactly at the summit, but off, clearly in the upper southwest rift zone, this big gas cloud rising up high enough to actually get to this separate layer of, cause it to mushroom out here, separate layers of atmosphere. So that was initial view. And I'm going to spend a little more time on this one today just because it's relates to what we just talked about a little bit. So the eruption began May 19th, 1916. So there we go, 109 years ago today. 106 years ago, is that what I said? 106 years ago, not 9 years ago. Thomas Jagger had founded HVO in 1912, only 4 years earlier, and had attempted to forecast Maunaloa based on a pattern of rifts and eruptions of the volcano since 1868. The previous eruptions had alternated locations between a northeast rift zone and a southwest rift zone, though these were frequently separated in time by eruptions confined to Mauna Loa's summit caldera at Mokua Ve'oveo. Mauna Loa erupted in 1907 from the southwest rift and 1914-15 from the summit. Therefore, Jagger hypothesized the next eruption would be from the northeast rift zone, right? Assuming that prior pattern meant there was an underlying reason for alternation of rift eruption sites. However, despite his prediction of the northeast rift zone being the next one to go because of this neat pattern that existed, instead it was a southwest rift zone in 1916. But also actually was the next 4 eruptions were all southwest rift zone, breaking the pattern. So they changed their paradigm from thinking of it rather than flipping back and forth from one to the other. Maybe it's more like a coin flip model where it's 50-50 every time. So long term, the odds might be 50-50. But it doesn't mean you can't flip 4 tails in a row. And perhaps that is how to think of this. So, like many eruptions, that eruption in 1916 was preceded by many earthquakes. Residents of Kau felt many earthquakes early in the morning before the steam plume showed up at 7:15 a.m., marking the start of the eruption. This high elevation area technically is considered a summit area, lasted less than 24 hours of activity up there. Later, another swarm of earthquakes shook Kau residents as lava intruded lower down in the southwest rift zone, resulting in line of fissures opening in the lower southwest rift zone on the evening of May 21st, so 2 days later. Lava from vents spread over the crest of the rift zone, feeding flows on either side. Maunaloa flow moving down a steep southwest side, and the large Rakahuku flow more widely to the southeast. The branched nature of the 1916 eruption, with the eruption supplying flows to both sides of the rift zone, coupled with a relatively small total erupted volume, ensured that the lava flows did not travel very far. Only one homestead, the Bertelmans, was destroyed during the 1916 eruption, which ended in May 31st. So only 2 weeks overall. And here's a map. It's this light blue 1916 right over here. This is a Honomalina flow that moves to the southwest right over there. Right, that's that part of it. The southeast part is a Kahuku flow right over here. You can see the axis of the rift zone coming down. That right there and this way as well. The axis of the rift zone. The flow is spreading across both sides. So what's noteworthy is that there are situations. 1916 is one of the few where the lava comes out. It actually spreads both ways in the rift zone, and there's not enough volume for it to actually get to the road. So here's a southwest flow that goes quite a ways, many miles, but does not quite reach the Circle Island Road. And similarly, in Kahuku side, travels a long way as well, but also does not reach the road. It's one of the few eruptions that does that. You can see that previously, 1868 cut off the road, 1887 cut off the road, 1907 in 2 places, leaving people who would have been in between. It would have been forced to go downhill to escape, right? 1926, you can see that this northeast side did not reach the road, but the southwest side did. Now all the way to Miloli'i. 1919 focused mostly on one side, so did make the ocean, and really the Big Daddy eruption that we worry about happening again is 1950. 1950 went down both sides, but the volume and the rate was so huge that even though it did that, it went down the southwest side and reached the ocean in 3 different places, all within a few hours. Right? So a kind of worst case, 1950. Best case, 1916. This 1916 flow, you might note here, doesn't actually even come onto any of the current ocean view footprint. It's all further uphill than that. Okay, so that's one key point because we're worried about that road getting cut off as one of the big impacts and things to plan for during an eruption of Mauna Loa. So they discuss that all those different flows from Mauna Loa's southwest rift. lava flows from 1950 into the ocean within less than 24 hours of that eruption starting. The repeated 1950 eruption is of great concern today due to the increased population in the area. So, what can we learn from Mauna Loa's 1916 eruption? The eruptions in volcanoes exhibit patterns. They do not always follow them. While repeats of most recorded southwest zone eruptions would at minimum cut off Highway 11, the smaller 1916 eruption demonstrates this is not always the case. So, over the past 200 years, Mauna Loa rift zone eruptions are evenly divided between a southwest rift and northeast rift. However, that run of 4 southwest eruptions in a row, beginning, right, 1907, 1916, 1919, 1926, shows a weakness of that long-term probability model in forecasting eruptions in the short term. It's a constant reminder that none of us should grow complacent living on our volcanic island, right? So there is that example, 4 southwest rift zone eruptions in a row. It might kind of fit more 50-50, but there's a lot of nuance in there, right? And kind of one thing I'll add here is that the way that we've categorized these eruptions, right, as having a summit phase and then a lower rift phase also plays into this as well. And sometimes it can happen within days of each other, as was the case here in 1916. But sometimes there can be a longer gap, and that can kind of muddy the pattern a little bit too. And if you take that into account, you can maybe clean up the pattern a little bit. But still, all that being said, you can never really predict things based on patterns, is the point, even if you try to clean them up as much as possible. So that's our Volcano Watch this week from Maunaloa, 1916. You can check that out on hawaiitracker.com if you want to see it, read it for yourself there. All right, so now we're going to switch gears a little bit, and we're going to transition back to looking at 2018. And last week we talked about the summit collapse. I thought I would play this video again, taken from the USGS web camera, of the changes of the summit, that whole summit collapse sequence itself, kind of to connect us back to last week. So we're focusing on a summit more so, and the collapses and the earthquakes. There's a view of the 3 months of change with that whole crater floor dropping out. At the edges, those down drop blocks, they're still dropping in, even in that 3rd month going in there. So comparing before and after just gives you some idea there, right? Let me pull it back here. Pull it back here and try to zoom it in. It's a little bit tricky to see here, but there is that active lava lake in Hale in 2018, and I can get this bar to disappear. I guess I can't. But the lava level now is not up to this ledge here yet, so it's still below, down over here, right? So that gives you some idea visually of where the lava level is now compared to what it was, right? Except there's a whole bunch of stuff, a whole bunch of other earth missing from this view in this crater all through here. Okay, we promised you last week I would show you this video, a video of the USGS earthquakes occurring at the USGS Hawaiian Volcano Observatory / Jaguar Museum. And so this is there's 2 sequences. This is kind of looking at the main sign out front, and then we move around onto the pathway by the actual overlook itself, where you'll see the earthquake occurring, cracks opening and closing visibly, the sounds rocking, and then in the background you see the crater with all the rocks falling down the crater walls during that collapse event, all the dust rising upwards, and then the sound of like the roar of the rocks kind of tumbling and all that. So I'm describing it all now because I'm going to be quiet and hopefully let you guys listen to the sounds of this. So here it is. That was a crack opening and closing. Here comes the dust. There's the roar. All right, there's that video, just to kind of tie things up with last week. And focusing on the summit, I thought I would also talk a little bit about the gases in 2018 to start off here. And we've had publications since then, kind of summing things up. So I'll show you guys a couple of just gas plots of 2018. And we're looking up here. This top plot is a summit, Hawaiʻi, and the bottom one is Pu'uʻo, right? So looking at the top one first, our rates here is in kilotons per day, so 1,000 tons per day, right? So we mentioned before that the average from 2014 to 17 was 5,000. There's the average right there. Okay, so during the first few fissures in the Lower East Rift Zone, everything was still normal range as far as gas at Hawaiʻi. There was one explosion May 23rd that got a bit higher. We're looking at something like 12,000 tons, maybe, in one day. But after that one singular high spot, it dropped back down. You can see that we actually went down lower to essentially close to zero until the eruption ended, and beyond that, in fact, right? So high value here of 12,000 tons per day. We move down to the Middle East Rift Zone of Pu'uʻo. Our scale is up to 1.5 thousand tons per day. So really, there wasn't as much here. Pu'uʻo collapsed early on, so these values are all less than 1,000 tons per day. Similar to the average from 2014 to 18, that stayed this way. You can see that in late August, there was a very brief little burp, we'll call it, right, where there was a little extra gas that came out. But that was short-lived, and it came back down to that average. And then really, since then, we've heard reports of it being close to zero. And so really, it's come down a lot more than the Middle East Rift Zone. So compared to now, you might say, okay, well, that's plenty of gas. That might be enough to account for everything between here and here. But ultimately, I'm showing you guys this to kind of shift the story back to the Lower East Rift Zone. And here's a plot of the gas for the Lower East Rift Zone for 2018 from Kern and others in 2020. And our scale here in kilotons per day, 1,000 tons per day, goes from 0 up to 450,000 tons per day. And our high value is actually off the plot. 609,000 tons per day was the highest value measured in the Lower East Rift Zone of 2018. 609,000 tons per day, right? And we're talking about now being in a range of 2 to 3 to 4 to 5,000 tons per day, and that being my normal, right? So to the max, record is 609 kilotons per day off the chart up here. But even without that high value, you can see that as eruption progressed, you can see there's like a mode value and then some error windows in here. Right? That's why you see these different color stripes. But essentially, think of it as one average like this coming in, right? So the highest average values, you might say, might be around 200,000 tons per day. Right? Early on, you can see that it went from 0 to 50,000 tons per day within a week, and then climbed higher and higher and higher. You can see there were a couple possible small gaps in here as things adjusted for some reason. But overall, the pattern was lots and lots and lots and lots more gas out of the Southeast Rift Zone than anywhere else, right? Anything in the summit was essentially drowned and was basically just a drop in a bucket, really, when it comes down to it. So here's a view of the PG cam before it went offline and was burned by a wildfire, looking at the lava channel and a lot of gas and steam. Just as an example of some of the effects that all this emission had, right? Not just the emission, but the heat itself, right? So you can see here there's like a little bit of one of these lavanados that we've described before, a little vortex of this gas rising up. You can see there's several columns of gas rising up here, not just from the channel area, but also from the surrounding flow fields and other fissure line, which is more in here. So I'm going to show you guys a different version of this. Not exactly the same photograph, but this is doctored up by our friend Harry Durgan, who has enhanced this view. So you can really see more vividly what that might look like. And that daytime views. And the nighttime views. Always a cloud hanging over the eruption site that you could see the glow reflecting off of just about all the time. Lots of gas around. For those of us that were at the hub, this was the nightly view of the sky there. I've able to find this low resolution animation of satellite imagery here of the island. This is an example that really shows this massive extra atmospheric cloud coming off the eruption site right there, right? So you see the regular clouds blowing with the trade winds coming across. That's what all these other white stuff is. But then this thing is different. Right? That's the combination of all the gases coming from the volcano there. So really, certain days were really, really dramatic, and this was one of them here. Stepping back now to the third week of the eruption, rather than those larger generalizations here. This is a video from Hawaii County Civil Defense, an overflight of that fissure line on that third weekend. So I'll show you guys this as a reminder and kind of an overview of what the situation was like at that point in time. There's our main fissures, PGVs at the bottom right out of view here. We have rivers of lava moving to the south towards Malamaki over here in this area. But these fissures are maybe 16 through 20, more or less, right through there, right? And then we're coming across here into the areas of Kahakai and edge of Leilani here, and the rest of the fissures coming through Leilani. I'm just doing a quick version of this. You guys want to get the full recap. Dane has this whole Drones On series with all this drone footage where he's narrating and recapping all this stuff, right? I'm just kind of just picking out one moment in time here just to show you guys the extent of lava in Leilani at that time, before fissure rate reactivated, before Ahu'aila'au burst forth in its full power and form a channel. That's still to come the following week. So we'll talk about that phase of it next week. As you can see from this overflight, even in those early days, the extent was dramatic. You can see video is still going. We're still coming across Leilani here with more and more streets cut off by the flow. And you see all the gas coming from eruption site, right? Eruption site, from vegetation and structures burning as well. That was one of the main sources of that gas, but of course also the heat from the lava flow itself was causing those weather effects too. There's that southern edge of Leilani. There's the last three fissures there in the forest just south. And I'll leave it at that. I'm not going to show you guys too many of those videos. I have a little selection picked out here that I think will be enough as it is already, especially if hopefully not triggering too much, right? But just bringing things up to address them here. We're looking straight down from a drone on a fissure line, and that flow is the one that's going to the south. Was a first ocean entry of this eruption, actually, right? So through the first 2 weeks, lava was all that kind of gooier, stickier, slower moving variety of lava that did not flow as far. Some of the lava flows did go, good distance towards the ocean. There were some flows from the eastern tip, fissure 17, 18, 19, that were moving south, but which weren't as fluid as this and didn't ever make the ocean. Whereas this one, past all of its branches, did make the first ocean entry in that third week of May 2018. So that was something that was different. That's worth noting here. Let's see, I think we're going to pan back. Dane?
Yeah, I was just thinking about this whole, because this was really the phase change from that entry phase where we had that thick, viscous lava that we dated back to the 1955 eruption. And then also Fissure 17, which was audibly loud and intense, but didn't put out much of a lava flow to speak of. And then we went into this phase where we started to see that real volume coming through the system. And we thought that this was kind of, this is the bad part, but it wasn't even the bad part yet. in terms of what's coming down that pipeline.
Yeah, you'll hear me say later on from the very, very beginning that the worst was still to come, and we'll get to that here quickly. I think with the geologic lens, there were some things that were obvious early on. That's why I was trying to share with people to be aware of what was coming still. And that was really the crux of it. We knew it was going to get a lot worse, and it was going to last a while, right? So we'll come to that here. Let's look at the ocean entry in the daytime. Another Hawaii County video here. This is a couple days into it. That ocean entry only lasted a few days, really, but it had a couple branches, like a western branch and an eastern branch. That later on, you'll hear us talking about this eastern branch shutting off as a change up rift. A big crack opens up and steals this river of lava back underground. But the western one continued for a little while, but in the grand scheme of things, really not that long. Right, this was the first wake-up call, I suppose, that lava was gonna not stay within a rift zone, but flow out to the south and reach the ocean. And this was that first sign of that, the first evidence of that. Since we're talking about gas, I thought I would show this video as well. This is the famous methane video from Kahukai, right? So I'm talking about gases today. I was throwing on a random one here from the vegetation itself burning, and that dense gas filling the low-lying cracks and igniting and giving you guys some of these pretty surreal, eerie views with blue flames with the red lava flames and the asphalt burning and lava fountains, and the smells and the sounds and the stink is something that's really hard to convey after the fact here. But continuing the effects of the gas, I thought I would play here. This is a video of Ikaika's, a very short update he did from Opihikau. You know which one this is, Dan? The one where he's talking about the effect on the vegetation and the leaves. So it's a short one here. I'll probably play it, most of it here, and let's listen to Ikaika, who had been updating an eruption for quite a while by this point in time already.
Good morning, everybody. Today I'm in the morning. This is my update, but we can't go live because there's no service here. We wanted to check out our neighbor communities around here. We are in Opihikau right now, and the SO2 levels are horrible, are bad. It's actually like 5 parts to 1,000. So yeah, I wouldn't be down here, but there's tons of people down here. I'm gonna post some pictures of how everything looked down here, but it's bad. Okay. And the SO2 level, but check this out. We've been checking this out over here, and just wanted to show everybody what I've been seeing all around. So all the trees out there is dying. Check it out, all green leaves all on the ground. Check out the green leaves falling. Tons of green leaves falling. Hold it. And you guys can see so much green leaves falling over here. You guys see all the green leaves falling? All in the background. So this is Opihikau. This is bad SO2 levels. Anybody, we can donate some stuff to Opihikau people. They don't want to leave because there's a lot of people that looting down here. So if anybody out there can donate some masks for Opihikau people, check it out. So much leaves dying, dropping. Look at all the leaves. All green leaves. Alright, just checking out the neighbors with the crews. Woo! Hello, everybody. Have a good morning.
All right, Dane.
So a few things there just to add some context. Where he is probably about 2 miles downwind, directly downwind of Fissure 8, or it wouldn't be Fissure 8 at this point, or I guess it would be, but all the vents that are emitting all the gas. It's about 2 miles away, I guess. This place got bad, though. He was saying it got up to about 4.5 ppm, which, so just to give like a baseline of that, with the National Guard, they started to really care at 1 part per million, right? 1 ppm. That's when they started to be like, all right, everybody needs to put on masks and stuff like that. At 2 ppm, it was, even though you have a mask, we need to leave the area, right? So he's saying it's 4.5 there. The thing is that some nights on the eruptions, the police, the HPD, would go down and take samples as well as USGS and anybody else that had one of the devices that to get a reading on it. And the highest number I remember was 11 ppm, and that was OPE cal. And that's just unbelievable. Like, that's thick right there. So yeah, all that place just got nuked with all the SO2 compared to other areas that are just outside of what would be the dominant wind pattern, and they're green still. Like, they didn't even lose their leaves. Just such a contrast.
It was really striking how localized that could be, right?
Yeah.
All right. So, anything else on that one?
Last questions? Oh no.
There's a couple moments there. Yeah. They're kind of embedded in there. Like, that may have been a moment that call for gas masks really was heard around the world. And then after that, from that point onward, we started getting lots of gas mask supplies that we were able to distribute to people, right? Although there were problems with that. That was kind of that first call out, and from that point on, everyone was really mobilizing for the gas. That was kind of I think that wake up call video. It was worth mentioning that.
It's where we saw every type of gas mask and every type of filter possibly ever manufactured during that eruption. I was trying to figure out, like, what goes with what? Does this click onto that one? Okay.
Yeah. So certainly some challenges there. Yeah, interesting to think about that. So moving on, here's another video. This one is actually 4 years ago today. Lani Puna, shot by Ikaika. You can hear a little bit, there's some wind noise, but you hear a little bit of the lava flow as well. Some view from the ground. And the lava would just tower over your head. And 180 degrees across your view as well. A lot of albizia trees burned in this area. You hear I mentioned that in the video. These are the views from the ground. It was spectacular, intense, devastating, sad, right? All those things, wondrous, all at the same time. Huge waves of lava splashing over the side, building these hills before our eyes. Playing, like, some of the areas would stay fountaining higher, others would get lower. You see them change heights. It would almost be like a whack-a-mole sometimes. You'd see them moving differently, right? All those different fingers of that blade of lava that came underground just popping up everywhere they could. And almost that eerie quiet when it's just fountaining and flowing and not actually burning and crackling and popping there. Anything you want to say there, Dane, about this video?
No, it's just again the contrast on everything. And the one thing about this part of the eruption was how fast. So down where Kaika was, the leaves were falling off pretty quickly. But right by these vents, it's like a sandblaster, inverted sandblaster. Instead of removing rust, it adds it, and it will just strip the leaves from the tree in a day, type of thing. So we'd be watching these cams that would get set up. Guys would go out and film from the same location, and they bring up a video a couple hours later, and you can just immediately see the difference in all the vegetation that has been downwind of the vents directly.
Yeah, it was really something there. So those are all some short videos. I thought I would switch here and I'll play you guys one a little bit longer video. This is that first time that Kaika brought me on camera for an interview. And really, that was the beginning of the last 4 years of us giving you guys volcano updates. Some of you guys have been with us ever since that day. Others have joined ever since then. So for those of you guys who have joined since then, I thought I'd give you guys a benefit of looking back at kind of where this all began. A little window into what these updates were like in 2018. It was much more guerrilla style. We were just under the tarp with generators running and whatever we could. Sometimes there was, I think there were updates that the cell reception was so bad we've lost the updates to the void by now, right? But there are some recorded, quite a lot recorded that are still compiled for you guys, and all put together in a playlist on our website. So what I'll do is I'll play this video. Ikaika starts off talking about his boat trip past Pohoiki, and then we start cycling through questions that he's taking from Facebook Live at that point in time. And I thought it was interesting listening to this about the early thoughts at that point in time about what was happening with Eruption, and I'll let you guys see that. And Dane, if at any point you want to let me know to stop, just give me some kind of signal, yeah. All right, so here goes.
Hello everybody, good evening on this Sunday po Lapule Sunday. So just got off the boat with a bunch of family and friends. Some of my friends from Pohoiki, guys that want us, that surf Pohoiki, and some of my friends just around here wanted to see what was going on at Pohoiki. The roads are all closed. Highway 137 is closed because due to all the lava flowing across Highway 137 in the Malama Key area, and so we call that place Malama Flats. Sad day, scenes. We had to see it for ourselves of what happened at Pohoiki, and Pohoiki will never be the same because of this. I mean, just because, right in that area, close to Kilauea, where Pele first set foot on Hawaii Island, that's where she almost, that's where she pretty much went into the ocean. But two different ocean entries. I mean, tons of lava going into the ocean. Majority of them is lava. But Highway 137 is closed. It's all between Mackenzie State Park and Kilauea. And just to watch it from the ocean how the devastation of what happened was just incredible. It came so fast down the road, down to the sea, that it's pushed all these albizia trees into the ocean. So that whole place was all flooded with albizia trees, and just crazy. So with that being said, I have one of my friends here. He used to be a volunteer and volunteer for USGS, and he's one of the smartest guys I know. And his name is Philip Ong, and he's been around the hub from the beginning. On people that wanted to know had questions about the lava flow and all the eruption and what was going on. he's here today, but he's been, you know, kind of answering everybody's questions here at the hub with his expertise on geology and volcanology. So it's so fascinating to be right in his presence and learn stuff every day from this guy. So I'm going to be interviewing him. If you guys have any questions, feel free to ask. But this is Philip.
That's it.
How's it going, Philip?
That's it.
All right. So we were just talking about what was happening on Fissure 20. You know, Fissure 20 looks like it's starting to create. There's a huge crack. Can you tell us about that?
Yeah, so the crack was new this morning, and it's, from the pictures it looks like it's pretty wide and pretty deep. And it's taken most of the flow from that Fissure 20 and it's going into the crack now, filling that space that formed underground.
Do you have a picture of the crack?
Yeah, let's see.
Here. So this is Fissure 20. Right here. This is all Fissure 20, and right here there's a huge crack, or the lava is actually going into. So this right here, this is where the channelized lava was, right?
Yeah, it was coming, the channel went this way and down around behind the hill that way.
So it went down in this area and down over this. So this is all Lanipuna right here.
Yeah.
All Lanipuna. Some of the houses are still there. But this was one of the major flows that was headed towards Pohiki, that was feeding
the eastern flow.
Yeah, the eastern flow. So now, as you can see, this picture was taken today.
This morning.
So yeah, what do you think about that?
Yeah, so the real concerning thing here is that for a crack this big and wide and deep to open, there's got to be something pushing underground. Yeah, so the reports were that yesterday the GPS had stopped moving, but would suspect the ground has been moving again today to allow these cracks to open up. And the concerning thing about this is that the reason this is happening, it's probably being pushed by magma from behind. So we know that Pu'o lava is starting to emerge from the fissures now, but it seems likely that being pushed from behind by the Halemaumau lava, that the surge of the flow is still coming. That's a big concern. Yeah, so we've seen increased output, but still at moderate levels, and it seems like with that's still increasing, and we're not sure how much it's going to keep increasing.
And just all by earthquakes or anything, you know, monitoring earthquakes up on the rift zone.
Yeah, there haven't been as many earthquakes, more at the summit, as the summit's still kind of sagging because all the magma left. If there's any kind of silver lining, is that, you know, that magma there is gone. That means at some point we're going to run out, or at least have a lower supply of it. But that's not going to happen probably for a long time. Yeah, it could be several weeks, it could be a few months even potentially before that happens. So the key point is that this is still, as much as we've experienced as humans, this is still the beginning of the main eruptive phase of what's going on with this lava.
So you think, what you know, as far as like you know, the extent of the flow, so what we're seeing now is just a beginning of a huge eruption.
Yeah, so I mean the main body of magma that's from Pu'o and Halemaumau behind it combined is just starting to arrive in the last couple of days. Wow. And it took, well, we could guess maybe a couple of weeks to get all the way here and all the way out, right? So it's not unreasonable to think that it might take a similar amount of time to get all the way out again. Yeah, a few weeks would be a reasonable guess. Although the caveat is that with this much pressure being pushed in, there could be cracks opening up anywhere along the rift zone that allows this pressure to come out. The more it pressurizes, the more unstable it becomes, yeah.
So this whole east rift zone could be jeopardized. Even Highway 130 could be jeopardized still yet, right?
It could be, yeah, still uprift for 130. It's still possible that the pressure is enough that it unzips it downrift to Kapoho. That's possible also. I mean, the whole east rift is still in play, unfortunately. We hope that it kind of makes use of the outlet that it has now that's made all the way to the ocean, and presumably is forming a big lava tube, but there's no guarantee of that happening, even though that's what we hope for.
So that crack that developed today has also just been sucking a lot of lava into the crack. So, you know, the question is, you know, how big is the crack, and how much lava will it take to fill up this crack, right?
Yeah, and then what happens next? Does it spill over, or does it make use of the western vent that's going to the ocean and bypass this eastern vent? It's all this stuff is just like the shape of the nozzle of the eruption at the surface, and what's happening right under the ground is just or more as important to figure out which way it's going to go.
So one of the questions that we just heard from Tiara Kilihomalu, could lava flow down in other areas as well?
Yes, it could. I mean, not without something big changing first, right? So a new crack has to open up somewhere for it to start flowing down there. So we could look for that kind of change happening, but as we've seen, that can happen pretty fast. Yeah, just like we saw with this Fissure 20 opening up, that can happen pretty fast. And you would expect a lot more cracking as the big bulk of the magma is arriving in the area. So you should expect a lot more cracking happening. The ground should be moving quite a bit. Where it pops out, no one really knows.
And also, by Ryan Finlay, has a tube formed yet, do you think?
I don't know for sure, but I'll be surprised if it's not forming as we speak. Yeah. Especially that western flow. The eastern flow, now that the source has been cut off at the rift by that new crack, it may be collapsing before it has a chance to fully form. But that western flow seems likely, like the longer it's established, the more likely it's established into a wall form too.
Another question by Wailani Gonzalez. I read something saying that the hotspot is more under Lo'ihi than Big Island. Is that true?
Well, so the hotspot is an area that's kind of ambiguous. We don't exactly know what we mean. Different people say it means different things. But one thing we can say for sure is that there's 3 volcanoes that have been very active on this corner of Hawaii Island for a while. That being Kilauea, Maunaloa, and Lo'ihi. So the way I imagine the hotspot myself is like a circle that includes all of those volcanoes. Yeah. So it is kind of moving towards the Lo'ihi side, but it's still very much underneath Maunaloa especially, and obviously Kilauea as well.
Can it open down Maunavale, even Hawaiian beaches? I don't think so, right?
Hawaiian beaches is off the rift zone. Maunavale is slightly off as well, and right now Maunavale sits to the north, and most of the flow is protected by a ridge from going that direction. So Maunavale, at least for now, the current situation is not looking that bad, but it's not impossible that the crack opens up, and if it doesn't happen this eruption, then people got to understand that this area of the rift zone, this is what happens decade after decade after decade, right? What's been unusual for us is that the last 35 years, it's not been moving, it's been stayed parked at Kuo'o. That's the unusual thing. In the age of social media and documentary TV, we've all been seeing everything about Kuo'o and used to it being in the same place and not changing a whole lot year to year, at least from an outside perspective. But that's actually been unusual, right? What's normal is eruptions happening intermittently here in the area, maybe every 5 or 10 years, something like this happening. So it could be that geologically this is more normal, and we're just catching up as people to understanding the reality of that.
Another question, what caused all this to happen in the first place? Bianca Yamamoto.
Well, fundamentally, it's magma that's coming up through the earth, from deep in the earth, coming up underneath Kīlauea volcano, coming through the hotspot and through Kilauea's pipeline. And then within the surface, that plumbing is dynamic and it's changing very often. Yeah, so the pipe can be different sizes. It can change depending on the earthquakes, depending on the orientation of how it goes, and how much it pressurizes, how easily it can get out of the ground. Right? If you have a big open hole that it can pour out like Kuo'o and flow to the ocean in a nice lava tube, you can get it out very easily. But if that cone collapses and the lava can't get out as much, maybe it backs up, and maybe it backs up all the way to the summit. Yeah, so I don't know what the mechanism was exactly that caused it to stop and back up, but clearly it's been pinched off for a while. Yeah, because the lava from Kuo'o before this eruption had decreased in volume substantially to the point where it was backing up to the lava lake at Hawaii Mau and spilling over at the summit.
Do they expect higher fountaining as more fluid lava arrives in that portion of rift zone? Dardy Gamayo.
That's an interesting question. Yeah, I can't be sure, but my gut feeling is the fountains are not going to be gigantic, if that's what you're asking. Not in the order like 1,000 feet like it was in Kapuho. The reason why is we've already established a path out to the gas that come out bubbling and mixing with the lava. Yeah, this reminds me more of what we saw at Kupainaha, where you had a series of fissures that bubbled up and made a lava lake, lava pond, and then flowed lava tubes to the ocean from there. So we could expect these similar fountains we're seeing now, where it's maybe 100 meters in that order of a few hundred meters. Not a few hundred, a few hundred feet or 100 meters or so. But not anything gigantic like Kapuho or Kilauea, just because we haven't seen the buildup that leads up to that happening as far as the gases involved.
And then Ryan, in 1955, the flows started down below and worked their way uprift. What caused them to move uprift? Could it be possible?
Yeah, they jumped around quite a bit. I think the first flow in 55 was around Leilani. It jumped down towards Kapuho, then back uprift. Yeah, so it kind of bounces back and forth. But the way that I imagine it is that magma is kind of wedging its way into the rift zone, and for some reason, it doesn't get past some point that's pinched in the rift zone. If that happens, it can kind of back up and work its way back up the rift. If enough pressure builds, it can open that crack and move back down the rift. So it can go kind of either way depending on how strong the rock is and what's holding it in. And it's kind of a game between how strong the magma can put pressure on the rock and how easily it can crack open back up the rift at the same time. So that's something that's really impossible to predict. We just know it's very pressurized and that kind of thing is likely to happen. Couldn't tell you where exactly though.
Can Pu'u and Halimau will refill?
Halimau will definitely refill. It's just a matter of time. It could be years before that happens, but that's just a matter of time. Pu'u itself is kind of it's a surface feature on a landscape, yeah, and whatever was feeding Pu'u below from the rift zone, that seems to have been destroyed. The collapse of Pu'u and the fact that we have that deep crater in there now would seem to indicate that whatever plumbing was inside of that thing is now destroyed and gone. So lava could pop open somewhere near that area again, certainly, and it will someday for sure, but maybe not within that crater itself. And whether you want to call it Pu'u at that point again or not, given that's going to have a rebirth, so to speak, that's a different question entirely.
Is there any, concern about Maunaloa? Because a lot of people, that's one of the biggest questions, Maunaloa erupting again.
Well, so Maunaloa is going to erupt again, that's for sure. And it's going to happen sooner than later. It's going to happen in our lifetimes, yeah, that's for sure as well. But it does not connect to Kilauea and what's happening in Kilauea right now, at least directly, right? I mean, the magma from Kilauea, is separate from magma that feeds Maunaloa. So there's no connection there, and the eruption of Kilauea by itself doesn't have to affect anything on the magma from Maunaloa. The volcanoes do lean on each other, so it could be that by Kilauea moving, it allows Maunaloa to move a little bit as well, and that could have some longer-term implications. But for the moment, short-term, no, there's no effect. The Maunaloa effect is not something we're worried about right now.
Is the cinder cone forming from Fissure 70 possibly be the new active zone replacement for Pu'u?
That's been a popular idea, but recently I'm tending to think no. The reason why is the most recent USGS data that I've heard from that fissure is that it's erupting kind of lava we call andesite. All that matters is that's an older lava that's been sitting in the ground for a while, and they weren't sure exactly how long it's been there, at least since 55, but possibly 1924, possibly from 1840, so it's been there for a long time. And the longer it sits there, the more the crystals can form there and then change the chemistry of it and makes the lava that's left over a lot stickier. And that makes it so that it can trap the gases more. So when the gases try to come out, they can't just bubble out in a regular fountain. They have to break that sticky lava in order to come out. And that's why that event in particular is causing such loud explosions and shooting lava so far in the air, is because it's that older lava, right? And if that's the case, it's also not as fluid. So it's not going to go as far, then it's not likely to be the established conduit. So it probably got pushed from behind or below by what's coming from Pu'u now. And I would say that more likely it looks like that fissure 20 to 22 is where most of the gas and lava is coming out from Pu'u. At this time, that's the most likely main vent. Although that could also change very quickly.
And another last question for tonight is, why is SO2 such an issue with this eruption? That's from our cousin Amy Kīlauea.
I think my short answer is that it's coming out where people live. Yeah, it's been coming out from Kīlauea and from Maunaloa for a long time and in huge amounts. The difference is now it's where people are right within a short distance of it where the fumes are the most intense. They don't have a chance to disperse by going with the wind very far. And that's really the big danger. Yeah.
All right. So you heard it from Philip. He's my good friend Philip Ong. He used to be part of the USGS team.
Yeah, as a volunteer. Yeah. And just to have my disclaimer, I don't work for the USGS. Yeah, this is all my personal opinion and not representing what they're putting out, which is they're doing awesome work and they're doing a great job.
So hello everybody. Well, we'll be getting him back on camera later on, probably tomorrow, and ask. You know, I like to have him because he's so smart and he knows everything what's happening around our neighborhood. So tomorrow we'll be at the flow tomorrow, kind of watching what's going on, and we can have an explanation of what's going on. So, well, hello, brother Philip. Thank you for being on my feed here. And hello, everybody. And what we all say, stay classy, Bruno.
Stay classy, Bruno.
All right, Dane. So,
all right, got through it. Yeah,
I kind of talked a lot in the video, so I'll leave it to you to say some stuff.
Yeah, a lot of the old days of pointing a camera at or a cell phone at a tablet, the production value in that. No, but you know those old days were quite something. Wild times in there, and you know all those updates were really important coming through because there were times where just the information that came through official channels was so far away from being sufficient for the people that were going through it. And people were always looking for somebody that knew what they're talking about, or even somewhat knew what they were talking about, because it was really weird at that time trying to get information out of people. It was very strange. So yeah, these streams popped up, and then they've just been kind of going ever since, and getting more and more production value behind them, especially after the eruption when we could finally breathe. And yeah, it's kind of been on that track since.
Yeah, for sure. I honestly, I don't know if I ever would have done it if Ikaika hadn't made us, basically
Right.
shoved that camera in front of me and started asking to see pictures, and kind of we've gone from there, right? I mean, I knew the USGS was really busy with the eruption itself, but I was shocked that there was no one at the hub or anywhere in the community actually answering the questions, very basic questions, and that's kind of why we started doing the updates in person at the hub. And then people started to disperse, and they were really evacuating elsewhere on the island or leaving the island, or people on the mainland who had relatives on the island were concerned, and it really became an online thing, much more so than an in-person thing. Early on, Ikaika was giving us updates live for everyone, but we spent most of our time talking face-to-face with people at the hub in those early weeks, and it took until this third week for us to really for Ikaika to really bring me on a camera to give himself a break. Honestly, he was kind of really burned out by that point in time already too. I mean, God, how tired do we look? I mean, I know we're all smiling, but man, we were so tired at that point in time. Kind of marvel that I didn't say more stupid stuff, or it was from being so tired.
Right. Yeah, definitely crazy times there, and the sleep deprivation and everything tied into it, and the adrenaline.
Yeah, but we actually knew quite a lot at that point, right? I mean, we had already figured out the Fisher 17 story. We've gotten a lot more details and the actual chemistry of it, but we knew at that point what was going on, right? I mean, it was like a best guess, but that guess was right.
Right.
We didn't know the Fisher 8 was going to reactivate, and that would be the main vent, but we knew it was somewhere the gas was coming out, and did not end up being 17, and we know. So
you're talking about it marching back up the rift as well.
We talked about the threat to Highway 130. Yeah.
Yeah.
And yeah.
And it did follow the thing where it's started off near Leilani or in Leilani, went down the rift even further, then backed up it.
Yeah.
That is kind of similar to the 55 model.
Right. Fissure 24 is just west of Fissure 8. Yeah.
Yep.
Yeah, exactly. I thought that was interesting. It's interesting to hear him talk about that, like at the very beginning, taking a boat down to Pohuiki, and already talking about the impact on Pohuiki would never be the same, just because the flow had come to the west of it. And little did we know that it was going to change a whole lot more before it was all over, right?
Right.
And it's still our focus today is that Pohuiki area. It's I don't know what else to say. It was intense. It was intense.
Yeah, I mean, if you want to see more, we do have the Drones On series, which is in a playlist on the channels and goes day by day through the eruption. Kind of shares all the footage that we have available and gives kind of some backstory and some of the untold things that didn't get portrayed in the media. Yeah,
so here's our YouTube channel. If you click on the playlists here, you'll see that there is all kinds of various playlists. But if you scroll down, you'll see that we actually have different categories. And if you go down far enough, you'll see there's a 2018 eruption category right here, right? So there's a Drones On series with the 32 videos Dane's put out, reviewing all that footage. We have some after the fact eruption coverage here, the list there, and this 2018 updates. It's got a lot of videos, 125 videos here. This is the heart of what happened to 2018 that we try to archive here for posterity. It's on Facebook also in some places, but good luck trying to search for it there. So for East, you can come on here and you can go back to the beginning where Kek is doing things all solo and then evolving from there into what we have going on now. So yeah, that's it for 2018.
Yep. All right. Well, see, I think we got like one question here to wrap up with.
Okay.
Is there any fluid? Richard asks, are there any fluid magma chambers under Maunaloa summit above the sea level?
Sorry, can you repeat the question?
Are there any fluid magma chambers under Maunaloa summit above the sea level?
Yeah, so it's thought that one of those upper chambers of Maunaloa might be more or less at Kilauea summit elevation, which is above sea level. Yeah. So I think early on, I think it might have been Don Swanson giving an orientation, standing at Uekahuna, and look towards Maunaloa, and at about your eye level might be the top of the magma chamber of Maunaloa. Of course, it's a large. There's some large networks, right? And it could actually it extends deeper than sea level, perhaps, but the top certainly above sea level. Yeah.
Right. All right. Well, I think that does it for us this week. We will be back next week, same time, 5 p.m. Thursday, Hawaii Standard Time, for another update on Kilauea and Maunaloa. Unless something changes, don't really expect it to happen, but if it does, we will go live and tell you what's going down. But nothing happens, I will see you next week and pass it off to Phil.
Yeah, mahalo, Dane. Yeah, thank you guys for sticking with us for extra long update tonight. We wanted to give a little more attention to 2018, of course, and put that in context of the VOG today, of course, which is obviously something to be concerned about. But 2018 was a whole different story, right? So yeah, until next week. I could keep rambling on, but I'll just wrap it up right here and talk to us in the comments. We'll keep going over the week. Until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong.